Okay, guys, yesterday we started talking about parabolas and the different ways that we can work with the parabola. We saw all of the elements of the parabola. We saw the different equations of a parabola, but we've only seen what happens when the vertex is at 0, 0. So I'm going to do another example where the vertex is also at 0, 0. So every time I'm giving you an equation, guys, the first thing you have to do is isolate y squared or x squared depending on what you have. So for example, this one says, find the elements and graph the parabola whose equation is 3x squared minus 12y is equal to 0. So to isolate x squared, you would have to take the 12y adding to the other side and the 3 dividing. Okay, so this would be your process. You take your 3x squared minus 12y equal to 0, and you take the negative 12y, you pass it adding, and you take the 3 dividing, and now you have it looking as the equations that we worked with yesterday. If x is squared, we know that it's going to be a vertical parabola. That means that it can either open upwards or downwards, okay? This number right here represents the 4p, so I would have to equal 4p equal to 4 to find the value of p, and now I have the value of p, which is 1. Once I have the value of p, since I know that the vertex is at 0, 0, and I know that p is positive, I know then that it opens upwards. Okay? I can find everything else. You know that the vertex is at 0, 0. You know that it's 1 unit up, so it's going to be the focus, it's going to be at 0, 1. You know that the directrix is downwards, so this one it's going to be y equal to negative 1. And then the lattice rectum, it's 4p. That means, guys, that 4p is going to indicate, the lattice rectum is 4, so that means that you're going to have 2 units from here to here and 2 units from here to here, okay? And yes, it has to go through the focus. This is the lattice rectum, all right? So the concavity is upwards. The vertex is 0, 0, the focus is 0, 1, the directrix is y equal to negative 1, and the axis of symmetry it's x equal to 0 because that's this right here, okay? The lattice rectum is 4, all right? So remember, every time you have a quadratic equation, you're working with a parabola, and if you have it this way, the first thing that you would have to do is isolate x or y squared, and once you have it isolated, then you can identify it. If it's an x squared, then you're talking about a vertical parabola. If it's a y squared, then you're talking about a horizontal parabola. All right? Here's another example. Now this example, it's going to show you, it's going to give you the elements, and you're going to have to find the equation. Now it's the other way. I'm giving you the elements and you have to find the equation. So what do? You have find the elements in the equation of a parabola whose vertex it's at the origin and it has a directrix of x minus 3 equal to 0. My recommendation, guys, it's every time I give you the information is graph what you have. So first thing they're giving you, it's that the vertex it's at the origin. So you know that you're going to have a point right here. And you know that the directrix, it's x equal to x minus 3, so you got to make it equal to x equal to something so that you can identify if it's a vertical line or a horizontal line. So if I have x minus 3 equals 0, you know then that x is going to be equal to 3. That means that you have a vertical line at x equal to 3. So with this, guys, then you can find everything else. You know that the distance between the vertex and the directrix is 3. So from here to here, you have 3 units. And if you have 3 units this way, guys, and this is the directrix, you know that you're going to be working with a horizontal parabola that opens to the left, okay? So if you're working with a horizontal parabola that opens to the left, then that means, guys, that you are working with something in this form. Y squared equals 4p times x, okay? Now with this, you know that p is 3. Just by looking at the graph, guys, from the vertex to the directrix, you have 3 units. Then you know that p is 3. But you know that p is going to be negative because it's opening to the left. All right? So if p is negative 3 Then when you substitute the negative 3 in here, then 4 times negative 3 would give you negative 12x. This would be the ordinary equation. And if you take this adding to the other side, y squared plus 12x equals 0, this would be the general form of this parabola. So now all you have to do, guys, is continue giving me the elements that we're missing. Concavity, it's left. The vertex, it's 0, 0. The focus, if the directrix is to the right, then the focus must be inside of the parabola. So that means that you're going to move 3 units to the left. So your focus, it's going to be at negative 3, 0. The directrix, you already knew it. The axis of symmetry is this right here, which is y equal to 0. And the latus rectum, it's 4 times 3, or 4 times negative 3, which it's negative 12. But remember that the latus rectum, it's always going to be positive because it's a distance. So the latus rectum, in this case, it would be 12. So that means that from the focus to a point on the parabola, you would have to do 1, 2, 3, 4, 5, 6 units this way, and 1, 2, 3, 4, 5, 6 units the other way. And then once you have those 2 points, you can go ahead and graph the parabola.